Okay, sorry for the delay here. Thank you for coming. This is the Adapt or Die session. This session is loosely themed around mobile authentication. Mobile as a platform is enabling some advances in technology. I view mobile as an authentication platform in addition to an application platform, but there are a lot of issues surrounding that topic. We're going to start with scaling authentication policy. That's what I'm going to present here in just a moment. And then we got Josh from TUFR that's going to talk about mobile as a platform. And then Carl is from BioNem that's going to be following on that theme with the use of things for authentication in conjunction, perhaps, with mobile. So with that, I'm not going to introduce myself except to say that I'm head of labs for Ping Identity. You can go and check out the bio if you have an interest. Let's just dive right in. So some of this you're going to have already seen. It's obvious, you know it. And part of it I'm introducing is brand new. Some of this you've never seen. Nobody's seen. So I have the great pleasure of talking for the first time about some basic research that we've done in Ping Labs. But before we get there, there's some context to be set. So this is a slide rather that I've stolen from Paul Madsen, one of my colleagues in the CTO group. And this goes without saying. I think most people sort of intuitively already understand that this trend is taking place. If you consider the three factors of authentication that are sort of the historical norms, what you have, what you know, and what you are, or biometrics. You know, historically, what you know has been the dominant factor. You heard Andre say this morning that it is sort of the, it was Patrick that said this morning that it is, sort of the state of the art, quote, quote. But because of changes in technology, the use of the mobile phone, a smartphone as the authentication platform, we're seeing the trend towards something else, specifically having the phone as an authentication factor is increasing the opportunity to reduce the use of passwords and also increasing the opportunity to use biometrics on the phone, local biometrics. And so we see this trend. But there's a lot more to that story, right? And the trend is, if you double click, so to speak, on what's really going on there, the use of the phone as a platform enables the opportunity to collect various types of context data items. So for example, geolocation or an IP address or user data, behavioral information. For example, what's in your contacts list on your phone, or the music library that you have might be used as a means of device fingerprint, for example. Usage patterns, time of day that the token is being used, how often it's being used, what resources it's accessing, etc. So we're seeing the use of context information in a way that it's not been used, or at least not to the degree that it's been used in the past, which is interesting because it presents some problems, specifically problems in how we talk about these issues, right? There's not a vocabulary that's been established, that is sort of settled, that describes how we describe each of these different context factors and what they are and what role they play and how they're fundamentally different from each other vis-a-vis the traditional factors, what you are, what you have, and what you know. So what I'd like to do is start there in establishing a vocabulary, a taxonomy. Obviously, part of this is being exacerbated because of IoT. One quick slide to say that. These things, if you will, not only will help us establish behavioral patterns and present back to the authentication platform, the phone perhaps, context information around that behavior, but also some of these things will actually directly assert identity, and we're going to hear about that today, right? So we have things that are providing information, fundamentally different types of information that will be used in different ways for the authentication process. So to the taxonomy, the proposed taxonomy. What we see is that there are active factors. Those, by definition, are factors that are used with the conscious involvement of the user, right? So a person enters a password, or they swipe their fingerprint, or they plug in the USB token into the computer, or they're using their smartphone as a hard token, right? Active authentication not only implies, it requires, in this case, the conscious involvement on the part of the user, as opposed to passive authentication. With passive authentication, we have, for example, a face scan or keystroke dynamics, just passively typing on your computer the characteristics that can be collected about the way in which you type says something about you. It can be used as an identifier, for example. Behavioral statistics. There could be geolocation, session cookies. There are a whole host of passive data items that are used or can be used as identifiers. By definition, obviously, the user is not involved in this process. It happens sort of behind the scenes. It's collected by the system without the user consciously being involved in the authentication process. But I think we need to split passive into two categories. One I'm calling continuous, the other one I'm calling context. Continuous, in this case, means that there's a monitoring aspect associated with the passive factors. It's easiest to understand that in terms of the biometrics, the keystroke dynamics, or maybe if you just are talking on your telephone throughout the day, the system in the background is collecting a voice print and continuously monitoring you are who you claim to be. EKG monitoring, context factors, these are normally sampled at one point in time during the authentication chain, but of course they could be sampled, right? You could continuously sample these context factors on an ongoing basis, and so in that context, pardon the pun, in that case, the context factors might be thought of as continuous factors. So there are some blurry lines here between context and continuous. And you might even suggest that, well, a face scan could be used as an active authentication method. And that's true, right? At the point of entry, if you will, at the point when the user is attempting to log into the resource or the protected asset, then we might actually use one of these continuous methods in the authentication chain. I'm not so much worried about that, right? The point of a taxonomy, the point of defining these categories is because the category names themselves help us talk about the authentication process and how these authentication methods might be used to mitigate certain threats, right? When we think about the threats that are in the enterprise or in our use cases, those threats imply the types of authentication methods that we should choose to mitigate the given threat. Okay? And so the category names are what I think are important. It gives us an opportunity to discuss or have a discussion around this topic in terms of threats, which has been difficult in the past. And then I'm going to make one more distinction, direct versus indirect. So direct authentication factors are factors that are actually sampling or measuring the person, the actual user, right? The person has to enter a password or a PIN, or you're scanning the person's fingerprint, or you're monitoring their keystrokes when they are typing. Indirect, of course, these are factors not associated with the person. They're associated with the device that the person is using. Perhaps it is the authentication platform itself, the mobile device. It might be the person's computer. Who knows? Maybe where their car is. When we have IP-enabled cars, et cetera, et cetera. But the point is, it's an indirect relationship. We're measuring the device and context surrounding the device as opposed to the person directly. So when we think about authentication, what is it fundamentally that we're attempting to do? I mean, we all sort of understand this but we don't necessarily always think of it in these terms. At 8 a.m., I get to work, I authenticate, I'm logging into Cloud Desktop for me at Ping, and by definition, that action is reducing the risk from the perspective of Ping that I am who I claim to be beyond some threshold. Right? Now, that threshold may not actually be explicit, but it's understood that there is a threshold. And definitionally, when I've authenticated, entering my password at Ping, I have reduced the risk below the threshold to the point where the risk is acceptable to Ping to give me access to the resource. Now, technically, what happens? Probably a cookie is being set, and the cookie has some expiration. And for the duration of that cookie, the risk is low enough by definition. Okay? Now, in reality, this level of assurance, if you will, the reduction in risk immediately starts to degrade. The LOA starts to decline, or you might say the risk starts to increase. Technically, it doesn't. Technically, it looks sort of like this. It's a step function. If the cookie lasts for 3 hours, at the end of the 3-hour period, when I subsequently try to get into Cloud Desktop, well, I have to reduce the risk again, right? And I do that by entering the password. What we'd like to achieve is something that looks like this. The goal is to have strong security without bothering the user. You know, security with convenience. The traditional axiom is that's not possible. The more degree, the greater degree of security, the less convenient the system is to use. So we want to solve that problem. And I would submit that the using mobile as an authentication platform is now, for the first time really, beginning to help us turn that curve. If you think about using a secure ID token, for example, it was always thought of in terms of a second factor. Why? Because it's less convenient in some sense than using a password. But with the smartphone as the form factor, something that you already have with you, and you always have it with you, the model, the mental model, perhaps should change, where the smartphone is the primary factor, and the password is the step-up factor for authentication. Why not? We have equally good security for most threats with more convenience. But let's take it a step further. The intent is to reduce that risk below the threshold using some set of authentication methods, and then maintain that level of assurance or that reduction in risk over time through the use of these passive factors, both context and continuous. So how do we do that? The traditional approach for establishing authentication policies, and let me just start by saying, I think that what we're really asking when we ask that question is, how do we build smart authentication policies? That's the fundamental question. We have the authentication methods, we have the data items, but building the set of rules that enable continuous authentication is not easy. It's difficult for humans to sort of figure out how to do that. And why is that? Well, we have our resources, some number of resources out there. And then if we only have a password, the policy is really dead simple, right? We simply, for each resource, require the use of the password. But when we start adding other factors to the mix, let's assume that we've just added a couple of more active factors, some type of hard token as well as a fingerprint. Now, what we end up having to do for each resource is somehow understand how to use those three different factors optimally by some definition of optimal. And I'm going to propose it has something to do with frequency of use and security, right? Minimizing pain to the user. All of a sudden, this becomes difficult. You know, it's represented. The policy is represented with a set of if-then statements, or perhaps they're Boolean expressions. We have password, hard token, fingerprint, some combination, arbitrary combination perhaps, has to be sufficient to give access to any of these given resources. Now what happens if we take it a step further? We're now adding all of these other passive factors to the mix. all of a sudden it becomes incredibly difficult, right? It becomes so difficult that humans can't actually write down the policy in a meaningful sort of way. You have very complex sets of Boolean expressions that are then included sort of as groupings in other Boolean expressions. The if-then statements become incredibly complex. So how do we address this problem? Well, one approach, obviously this means we can't scale, one approach is risk-based authentication. How many people in here have heard of or have used risk-based authentication? Oh, good. Excellent. So most of you know what this is. Instead of requiring the users to combine, or manually create the policy, we're going to simplify things. We're going to take some function of all of the various authentication method inputs, and we're going to boil them down into a single number. By the way, anybody got time? How much time do we have here? 23 after. We're going to boil these down into a single number. And then for each of the resources, we're going to establish a threshold. And if the risk score for this set of inputs is below the risk threshold for the given resource, then we're going to give access to the resource. All right? So this dramatically simplifies the process of creating a policy. The problem with this approach is that it's not expressive enough to create the types of policies we really are interested in creating. So for example, if I want to say if the risk score is not sufficiently low, if I want to include some notion of step-up authentication or fallback authentication with the active factors, then all of a sudden I'm having to write a set of rules around the risk score. I'm back to if-then statements, right, or Boolean expressions. Well, what if I want to say something like if the user is in the office and it's between the hours of 8 and 5 and the risk score is sufficiently low, then let them in. If they're out of the office and the risk score is sufficiently low, then require step-up authentication. All of a sudden, I'm back to this, right? I'm having to craft rules that include both knowledge of how the score was calculated. If it doesn't work, why does it not work? So the scale is still an issue with just RBA. So how do we solve that problem? I'm proposing something that we're calling threat-based authentication. When you think about risk is normally a function of assets or resources, vulnerabilities, and threats, right? But RBA has no notion of that. It's got this term risk score, but risk of what? It's sort of the general notion of the whole world is out to get me, right? So the risk score is not meaningful in the context of understanding what threats you should worry about. It just says worry. That's it. Something's wrong. You should be worried. Well, what do we really care about? We care about the threats. And so what we're proposing is an alternative model. We start with a list of threats, threat categories, if you will, and each of these categories are going to be specified based on how they segment the types of resources. So we might have man-in-the-middle attacks, we might have authentication, local attacks, remote attacks, etc. And then what we're going to do for each resource, we're going to specify how that resource is vulnerable to a given threat category. All right? And then subsequently, for a given authentication method, we're going to specify to what degree this authentication method actually minimizes the probability of success of a particular threat. That's what we care about. With that type of information, we can calculate meaningful risk scores, right? And if we want to add a new resource, all we do is specify for that resource the vulnerability, the degree of vulnerability for any given threat, and the same thing is then going to be true for authentication methods. In other words, we can scale this, right? This approach scales in ways that RBA simply does not scale. It also gives us information that we care about. Now, if in use, the first time through an authentication process, we're only using passive factors. And if those passive factors reduce the threats that we care about sufficiently low, then we're fine. Give access. But if they don't, if something's wrong, we can look at each of the threat numbers and understand why, which threat is it that is not sufficiently mitigated, and the threat itself implies the authentication method. We then build a policy that goes and it's trivial to build the policy that will then go and require the authentication method necessary to mitigate the threat. So here we have it. Risk-based authentication, RBA, risk isn't really a function of the traditional items or components of risk. It's simply a function of the authentication results. It assumes a broad general threat, sort of an antagonistic world. And the risk score is the same for all the assets. For any given resource, you get the same risk score. So it's meaningless in terms of understanding vulnerabilities associated with, or it doesn't take into account the vulnerabilities associated with resources. Threat-based authentication is what I believe is the correct approach. It's sort of the next generation, if you will, of this notion of using RBA, but in the context of user authentication, as opposed to credit card fraud. Right? It's reapplied, rethought. Threat-based authentication is the next generation of RBA. So it scales, it provides additional security for all the reasons that I've just described, and it actually makes life better for the end user. The result is that the user is pestered, if you will, less frequently with the need for active authentication methods than in previous approaches. Okay, so that's it. Any questions?
What are your categories of APT?
That's in progress. Yeah, so the question was, what are the categories? The categories are being defined. So this is research, by the way, that has been developed this year, since January. Yeah. Absolutely. Well, so I'm introducing it for the first time. When we have the threat categories, a proposal for the threat categories, then certainly we'll make that public, and that's something that vendors and resource, the SPs and the IDPs and authn vendors will need to eventually agree upon. Yeah.
A lot of folks doing all that budget now are starting to build the risk-based into all of their products. Is that something that Ping is going after them too?
So I'm head of labs, and labs is chartered with looking at next generation technologies, some of which will be integrated and used by Ping, and others will just die on the vine. So I don't know. This is early stuff. I'm hopeful, but we'll see. Brendan.
I'm curious how you're thinking around sort of some of the privacy ramifications when you start looking at gathering sort of information off the device, as well as even some of the non-privacy related things like, can you trust some of the factors that are being just used in the device, like say GPS, back to some of what Bob was.
Yeah. So I'm gonna start the question by saying I'm less interested about the actual authentication methods themselves. Each method is going to have its own, set of issues when it comes to the, this topic of privacy. And I'm more interested in assuming that those methods exist and that we can take advantage of them. And my focus is how do you build the policy that combines all of those? Okay, so thank you.